So, hello everyone. There is one more question from an interview based on time complexity. This is the piece of code or pseudocode given here. So, when we look at it, there is a function, and when you go through the function, if we see the same function is being called here again. So, we understand that this problem is based on recursion because it's calling itself here. So, now let's see how to find the time complexity of it. So it's pretty simple, and once we get the generalized formula in the next upcoming example, we can use it directly here. We have, as we have not solved much questions, we'll start from scratch here. So now if I assume that t of n is the time taken, t of n is time taken to execute this function sample int of n. Now if I assume that t of n is the time taken to execute this function sample int of n, what will be the time taken to execute sample of n minus 1? T of n is for sample of n minus 1, right? Therefore, for sample of n, therefore for sample of n minus 1, it will be t of n minus 1, right? So now what will be t of n is, if we see, it's called two times, right? Two times, and we know that it's t of n minus 1. So for this it will be t of n minus 1, and for this it will be t of n minus 1, and there is comparison right here. So comparison takes a constant amount of time, right? So write it as plus 1. So this will be 2 times t of n minus 1 plus 1 for t of n. So now let's see how to find out the time complexity. So now we have found out t of n. Let's call this as 1. Now let's find t of n minus 1. Okay. T of n minus 1 will be, substitute n minus 1 in place of n. So it will be 2t in place of n. I will substitute n minus 1. Minus 1 will remain as it is, and there is plus 1 later. So 2t n minus 2 plus 1. Let's call this as 2. So next, t of n minus 2. Again, substitute n minus 2 in place of n. So it will be 2t n minus 2 minus 1. Substitute in this, right? Plus 1. So 2t n minus 3 plus 1. This is the third equation. Now what we'll do, we'll substitute this 2 in 1. Substitute 2 in 1. So when we substitute 2 in 1, what will we get is t of n is equal to, write 2 as it is. Then in place of t of n minus 1, we have the value here. T of n minus 1 is this. So substitute that 2 into n minus 2 plus 1. Then this plus 1 we have not yet written, so write it. So this will be 2. We can write this as 4, but I'll tell you why I'm writing it as 2 square. It will be useful. So multiply to 2 square t n minus 2. You have multiplied this. Multiply this now. Plus 2, 2 raised to 1. And 1 can be written as 2 raised to 0. So this is what we got. Now, this was substituting 2 in 1, right? So now let's substitute 3 into this. This is 3. So substitute 3 into this now. Okay, into this. So 2 square, write it as it is. In place of t n minus 2, substitute this. 2t n minus 3 plus 1. Okay. So in place of this, I substituted it. Okay. Parenthesis is, okay, let's write the parenthesis. Then this 2 raised to 1 will be as it is, plus 2 raised to 0. Now multiply inside. It will be 2 cube t n minus 3. Multiply this. It will be 2 square. Then this 2 raised to 1, 2 raised to 0. So let's write the same thing in generalized form. I can call this as 2 raised to I t n minus I plus 2 raised to I minus 1, 2 raised to I minus 2 and so on, generalized. Okay, I'll not write this. This is generalized form, not for this example. It will be up to 2 raised to 0 or 2 raised to 0 is 1, right? So this is the generalized form. When you solve some more examples, when you practice more examples, you will arrive at some generalized form here. So it's not that generalized form will be exactly same for all examples. We'll see in the upcoming examples. Now one thing is now if I get rid of this n minus I, I'll be able to find the time complexity. So let's look at the base condition here. So when will it stop? When n is n is equal to 1, it just returns 1. So this comparison only is the one we have written, right here, constant time. So now when t of n is equal to 1, that is 1 means constant amount of time. When n is equal to 1, we know this. Why? It's given here. When n is equal to 1, it's returns time. So time, so it takes constant time when n is equal to 1. So now I can make use of this here. So now here I have n minus I. So what I can do is n minus I is equal to 1. Therefore, what will be n or what will be I? N will be equal to 1 minus I, right? I have brought it here, or we got what we could have done is directly write I equal to n minus 1, right? So this is what we would have got. So now just substitute these values here. Okay, so 2 raised to what is I? N minus 1. N minus 1 t. What is n minus I? 1. What is in place of I? Just substitute n minus 1. N minus 1 minus 1 will be n minus 2. So this will go on similarly when it's generalized, it will go on till 2 raised to 0. So 2 raised to 0, what will be the other term? It will be 2 raised to 1, right? So if we see this is in GP, okay, GP is geometric progression. So how do we solve GP? Common ratio. So I'll rub this, okay. So GP, common ratio. Now this is R2, this is R1, right? So what is common ratio? 2 by 1 is 2. So sum of all the terms will be Sn equal to A into R raised to n minus 1 upon R minus 1. This is the formula. R stands for common ratio. So what is the first term? A stands for first term. First term is nothing but 1. So write 1, and common ratio is 2, we found out. And see the number of terms in this series. Number of terms, how many terms are there? So if you see there are n terms. If you have not understood, I'll come back here. So R minus 1 is 2 minus 1. So this will be 1, this is 1, this is 1. So final answer is 2 raised to n minus 1. So this is nothing but order of 2 raised to n, right? This is how we write time complexity. Now why n here? Number of terms, why is it n? Can you make out? Now see, index starts from 0, it goes till n minus 1. So let's take example 1, 0 term, first term, second term. Okay, let's take it as number only. Let's say first term is 1, then no, okay, what we'll do is 0, 1, 2, 3, 4, 5. Now there are numbers from 0 to 5. So how many terms are there? 1, 2, 3, 4, 5, 6. So 6 terms are there. So similarly, we have here 0, right? From 0 we have. So I have written n terms. So how many terms are there? That will be the number. Now suppose if it would have started from 1, 2, 3, 4, 5. So if this was the case, if it would have started from 1, number of terms would have been 1, 2, 3, 4, 5. That is n minus 1 terms. But here as it starts from 0, number of terms will be n. So this is the time complexity what we'll get, that is after solving this recursion example. And base conditions are very important. That is where the substitution lies. So as and when you'll solve more examples, you'll understand why, means how to do it quickly. So if you're not clear, this is t of n equal to 1. This is clear, I hope. We okay, I wrote it here, right? T of n was 2 times t n minus 1 plus 1, right? So this took us t of n minus 1, this took us t of n minus 1, so this is 2 times, and for just one comparison it took 1. So this also signifies that when there is only one term, it takes constant amount of time. That is what we wrote here. So if there will be sometimes 0, so how to deal with that, we'll see that. But here, what does it mean? T of n equal to 1. I've written t of n equal to 1. Everyone says it's constant, but what does it mean? So whenever now, and I've not written just t of n equal to 1. I've written t of n equal to 1 when n is equal to 1. So it means when there is one term, it just takes constant time. So it is not going to go inside this, right? So that will be used as base condition while solving. So there are some more examples which will be related to recursion. In the next video, I'll give a brief introduction on recursion, then we'll solve more interview questions on recursion. So thank you.